Welcome guys to today's class. In today's video, we want to discuss alternative current or AC circuits. I repeat, alternative current or AC circuits. When do we say that a particular circuit is alternative current circuit? A circuit is said to be alternative current circuit if the current in that circuit flows in a reverse direction. That means if the magnitude and the direction of the current changes periodically, that it changes with time, we say that that circuit is alternating current circuit. Look at what we mean. In alternative current circuits, if you have this, a graph of current against time, the direction of the current will be like this. It will move sinusoidal pattern. Let's draw it well. This is with respect to time. When the direction of a current or the pattern of flow of a current moves in a reversible pattern, we'll say it's a alternative current circuit. When you have this way, or even the voltage, graph of voltage against time moves sinusoidal pattern. Look at what we call sinusoidal. Sinusoidal what? Pattern. Sinusoidal pattern simply means that it obeys sine graph. It obeys the way we draw our sine graph. Sine graph moves like this from 0, move like this, where here sine 0 is equal to 0. Sine 90, here is 90, here is 180, here is 270, here is, let's sketch it in a clearer pattern. So that you can see what I am talking about. Graph of current against what? Time. It obeys sinusoidal pattern. That is sine graph, sine theta graph, which goes like this. Are you getting it? That is where we say sinusoidal. That is, it obeys sine graph pattern. Now, here is 0, here is 90, here is 180, the middle 270, next 360. As you continue, you continue labeling it. Sine 0 is 0 because it's meeting the curve at 0. Sine 90 is meeting the curve at what? 1. So here is 1, whereas here is minus 1 for the down part. So it's obeying this direction of flow. Are you getting it? Now, when a particular alternative current flows like this, this is what we call the peak current. And from that peak current, you get your peak voltage. It is a peak current that we use to get a peak voltage. So here will be your peak current or peak voltage. That is the maximum voltage or maximum current you can get. It is gotten at that point. But when you talk about DC circuit, that is direct current circuit, you will notice that the direction of flow of the current is constant. Let's say the graph of current against what? Time. The direction of flow of the current will be constant. Look at how it will move. Constant. It shows it does not change with time. It is constant. It flows in one direction. That is the difference between direct current and alternative current circuits. In direct current circuits, the direction of current flows in one direction. It doesn't change. It is constant. Whereas in alternative current circuits, the direction of the current flows in a reverse direction. A reverse direction. It changes periodically. It changes periodically with what? Time. I believe you understand the explanation. Okay? Now, in direct current circuit, it is important for us to remember some laws which we use there. very well. One of those law is what we call Ohm's law. Ohm's law, what does it state? That current flowing through a conductor is directly proportional to what? Potential difference, as far as the temperature and other physical conditions are constant. We come up with V equals to IR, where R is called the effective resistance of the resistors in that what? Circuit. Are you getting it? The I is the current and V is the potential difference, which we call the voltage. Do you get it? Now, that means in a direct current circuit, it has only one type of what? It has only one type of material that opposes the flow of electric current, because we say resistance is the ability of a material to oppose the flow of electric current, or the opposition to the flow of electric current. That is what we call resistance. Whereas the resistor simply mean the material or any material that oppose the flow of electric current. Do you understand what we are saying? And so in direct current circuit, it has one material that oppose the flow of electric current, which we call the resistor. And so when we have many resistors, we have to get the effective resistance of those resistors. And that is why in one of our videos on our channel, we discuss how to resolve, how to find effective resistance of resistors in the circuit. And we noted that day that we have resistors in series and resistors in parallel, and we showed how to do that. So if you want to watch how to do resolution of resistors both in series and in parallel, do well to type Chidons Daniel how to find effective resistance of resistor. You will see one of the video that will pop up. Just Chidons Daniel. This is our channel name. Chidons Daniel. How to find effective resistance of the resistors. You will be able to see the video and you watch it. Okay? Yes. But when we talk about alternative current circuits, as we said, it's moving in reverse direction. And as a matter of fact, it will need many material that opposes rays of electric current, depending on the type of appliance we are talking about. It depends on the type of electrical appliance we will talk about. Yes. Now, these material that opposes flow of electric current are many. Normal pure resistor is number one. The resistor, it opposes flow of electric current. Capacitors, you meet electronic engineer and he will tell you your capacitor burns. Inductors, he will tell you your inductor burn. You will be like, what is he talking about? It means these are examples of materials that opposes the flow of electric current, so to speak. Yes. Now, in alternating current circuit, we say it doesn't have only one resistor. Like it has more than one material that opposes flow of electric current. Yes. For you to see is an appliance that goes by alternating current circuit having one resistor is rare. It is rare. So it will have either a resistor and a capacitor, a resistor and an inductor, or a resistor and inductor and a capacitor. That is why we come up with this. Now, it's important for you to note that the opposition to the flow of electric current offered by the capacitor is called capacitive reactance. Capacitive reactance. That is for the one on capacitor. You know that the pure resistor itself opposes the flow of electric current. Are you getting it? By the resistor. The flow of electric current, if it is opposed by resistor, we call it resistance, effective resistance. We call it effective resistance. But when the current is opposed by capacitor, we call it capacitive reactance. Also, the opposition to the flow of electric current by the inductor is called inductive reactance. Inductive reactance. And this one will represent it with SC, whereas this one will represent it with SL. XC means capacitive reactance, SL means inductive reactance. Now, opposition to the flow of electric current offered by inductor and capacitor. Are you getting it? This one, we'll call it that it is inductor capacitive reactance, like it's being opposed by both inductor and what? Capacitor. Are you getting it? In this one, we'll be saying what? XL minus XC to get our total opposition by these two words, these two materials. We can call it materials or components which opposes flow of electric current. You understand? In alternate current circuits. Now, as you have gotten this, now we said that alternate current circuits don't usually have only one resistor. It has more than one opposition, more than one material that opposes flow of electric current. It has more than one material that opposes flow of electric current, and we said it can have a pure resistor and a capacitor, a pure resistor and inductor, pure resistor, capacitor and inductor, so to speak. Now, if we want to get the overall opposition to the flow of electric current in a let's say appliance, in an appliance that has this in its circuits, which is to oppose the flow of electric current. If a particular appliance has pure resistor and capacitor as its material that will oppose the flow of electric current, now the overall opposition to the flow of electric current offered by these two, we will call it impedance Z. This one, the total opposition to the flow of electric current offered by the resistor, the pure resistor and this inductor is also called the impedance, whereas this one is called what? Also the impedance. Okay, so there is need for you to what? Note this. I will know why I'm cleaning this so that you not think that impedance times this. No, this is impedance. So impedance is a term that is used to show the total opposition to the flow of electric current in an appliance, in an alternating current circuit offered by what? Or that has pure resistor and capacitor, pure resistor and inductor, and pure resistor and both capacitor and inductor. So it's no longer only pure resistor that is in that circuit. That is what we are saying. Yes. So in this case, the total opposition to the flow of electric current will be called the impedance because it has more than one material that opposes flow of electric current. Now, this impedance for the first one is equals to square root of R squared plus XC squared. Look at it. The XC is called the capacitive reactance from these capacitors, while this R is the effective resistance of the resistors. Are you getting it? Now, it is important for you to note that XC is equal to 1 over 2 pi FC, where this C is called the effective capacitance of the capacitors in the circuit. What do we mean by that? When you have a circuit like this is what we call capacitor. Please don't take it to mean the same thing with this. This is a cell or battery, while this is equal size. This one is not equal. This is a cell or battery, the EMF, where we call the EMF. But this one, we'll call it the capacitors. Are you getting it? So let's clean this. We don't need this one. Now, these capacitors are said to be in series. They are said to be in series. Now, it means that the effective capacitance of these capacitors, C, this one that are in series, C, we'll be getting it from 1 over C equals to 1 over C1 plus 1 over C2 by reciprocal. That means our total C will be equal to C1 times C2 all over C1 plus C2. That is what it means by when you finish solving this and you invert it to get your C. It means this thing. That means if here is 2 farad and here is 3 farad, because the unit of capacitance, the unit of the capacitor is in what? Farad. The unit of what? Capacitance of a capacitor is in farad place. Now, that means I will just say 2 times 3, 6, all over 2 plus 3, 5 farad. That is about this. But when they are in parallel, are you getting it? We'll call here C1 and here C2. When they are in parallel, the effective capacitance of these capacitors will be C1 plus C2. That means it's like opposite of what you see in resistors. Are you getting it? In resistor, we say when they are in series, you add, and when they are in parallel, you get the reciprocal. But in this capacitor, it's opposite. When they are in series, you get the reciprocal. Then when they are in parallel, you just add direct. That means if here is 2 farad and here is 3 farad, we'll be having it to be 5 farad. Are you getting it? Please note this very well, because they can ask a question on how to resolve capacitors of a given circuit or in a given circuit. Please check up, are they in parallel or are they in series? If they are in series, please get the reciprocal as we did here. If they are in parallel, just add them up. That means when 2 or more capacitors are in parallel, their effective capacitance of the capacitor will be what? Higher than the highest. This is 5, the effective for this, and this is the highest, 3. So the effective capacitance of the capacitors in this circuit is 5, and it is higher than the highest capacitor. Are you getting it now? That is about this. But when you come to series, you see that the effective capacitance of the capacitor in this circuit is 6 over 5. 6 over 5 will be giving you 1.2 farad. 1.2 farad. Now, the effective capacitance of the capacitors in circuit that are in what? Series. This is series. Is always lower than the what? The least capacitor we have. The least is 2, so the effective must be lower than it. That is what will tell you that you are correct or not. Are you getting it? Please take note of this, because this is JAMB question and even some university year 1 question. Take note of it. Even some secondary school, WAEC, they can ask you this. Note that. That means 1 over 2 pi L. That means this my Z. This Z is with respect to this first one. So the Z will be equal to square root of R square plus 1 over 2 pi FC, all what? Squared. Then for this one, for circuit that have pure resistor and inductor, we'll be saying that the impedance of it is what? Square root of R square plus XL squared. Yes. And we said that XL is inductive reactance. XL is equal to 2 pi FL. The unit of this is Henry. The unit of it is Henry. While the unit of effective capacitance of the capacitors is in farad. This is farad from Faraday. This is Henry from a scientist called Henry. Are you getting it? So here will be Z impedance equal to square root of R square plus what? 2 pi FL, all what? Squared. Are you getting it? So you have to note this. You have to note this. Then for this third one, we said that the impedance will be equals to what? Square root of R square plus XL minus XC, all what? Squared. That is the impedance, the total opposition that will be offered by resistor and this. Okay, now we have noted this, and we said that XL is what? 2 pi FL, and XC is this. So that means it is equal to what? R square plus bracket 2 pi FL minus 1 over what? 2 pi FC all squared. This is for XL and this is for what? XC. That is just it. Get the one of XL first. Get the one of XC. Then put it into here and subtract and sort it out. That is the total opposition that will be offered by pure resistor, inductor, and what? The capacitors in that circuit. So there is need for you to note this information. When you are able to get this impedance offered or that is present in this circuit, you carry that incidence and impedance and multiply with the current in that circuit. That will be giving you the voltage in that circuit. Yes, that is what we are saying. When you get the impedance here, multiply by the current to get the voltage, because this is effective resistor. That means the total opposition to the flow of electric current in that circuit. That is this Z. Multiply by the current, you get the voltage. That means V equals to IZ. You'll be getting your voltage at every point. Are you getting it? Now, there is need for you to note that time we sketch this alternative current circuit. We said that here is called your maximum what? Current or maximum voltage. It is at this peak that you get the maximum or peak current and peak voltage. Are you getting it? It is at this point that you get the peak current or peak voltage. Are you getting it? Now, what about at all these points that are not the peak? How do we get the current? When you plot the graph of I against time, at this point you are seeing now, how do we get the current? How do we get the voltage? That means since this is moving in sinusoidal pattern, as we said, it means that the current at any point that is not the peak will be equal to I-O sine what? WT. The voltage will be equal to VO sine WT also, where our W will be equal to 2 pi F, where our W will be equal to 2 pi F. Therefore, that means our I will be equal to I-O sine 2 pi FT, whereas our V is equal to VO sine 2 pi FT. That is just it. That is just it. You need to understand the relationship between the peak current, peak voltage, and the current at any of these points that are not the peak, that are not at the maximum. Okay? Now let's also derive other important formulas we need to know concerning what? This. First formula we want to recall is formula for what? Current root mean square. Root mean square current, we say it is peak current, peak or maximum current all over root 2. Yes. Then voltage root mean square voltage equals to peak voltage all over root 2. That is first two formulas. Another formula we need to understand or know is, what do we mean by P maximum? P maximum means peak power. Peak power. P maximum can be called peak what? Power. So at that point we have the peak, then we have the power. Like that point we just what? This point that we have I-O and VO. This current is giving you this. If you are saying graph of I against what? T, this will become the peak current. But if you are saying graph of V against what? time, this will be called the peak voltage. So when you get the peak current multiplied by the peak voltage, you'll be getting the peak what? Power. The peak power. Now the peak power simply means I/O times VO. And what is our I/O? This times this root 2 I root mean square times what? Root 2 V root mean square. That is what we mean. Root 2 times root 2 will give you 2 from law of sort. That will be giving you 2 I root mean square times V root mean square. That is the formula for maximum power. Maximum power equal to 2 times I root mean square times V root mean square. You note it. Now, this I root mean square and V root mean square, they are known to be what? Average power. P average. That means P mass is equal to 2 times P average. That is what it means. The average power is equal to maximum what? Power. The average power times 2 is equal to maximum power. And also the average power is equal to 1/2 times maximum power or the peak power. It's also important for us to note, when do we say that resonance occur in alternate current circuit? Resonance occur in alternate current circuit when XC is equal to XL. What do we mean by XC? XC means 1/2 pi LC. That is the capacitive reactance. When it's equals to what? Inductive reactance. We said resonance occur. Resonance can also occur when we say that the impedance is equal to the pure resistor. Yes, because we had a formula that says impedance is equal to R square plus XL minus XC all squared. From this formula, it means that once this is equal to this, XL is equal to SC, they will subtract to give you 0. 0 square 0. This plus this R square. Square root of R square will give you Z equal to R. That is how we say impedance will be equal to what? Pure resistor for resonance to occur. Are you getting it? So there is need for you to note what happened here. Therefore, making F subject of formula here. When you make F subject of formula, you call that F resonance frequency. That F, that frequency will be called resonance frequency. It is a frequency that was gotten as this inductive reactance equals the capacitive reactance. And that will be 1/2 pi root 1/LC. Are you getting it? So we have set condition number 1. We have set condition number 2, and we said it is from here. And condition number 3 that will occur from here. Now, we also said that for resonance to occur, it means that power angle is equals to what? 0. Power angle is equals to 0 and power factor is equals to 1. You say that resonance has occurred. So it's important to know this formula, resonance frequency. They ask it very well. And formula for what? Capacitive reactance, inductive reactance, and how to get your effective capacitance of this capacitor. Very important. And also, there is need for you to note that if you are giving something like 2 mF, 2 millifarad, farad means Faraday, it means 2 times 10 raised to power minus 3 farad. If you are giving 2 microfarad, it means 2 times 10 raised to power minus 6 farad. If you are giving 2 millihenry, a microhenry, it means 2 times 10 raised to power minus 6 henry. If you are giving 2 millihenry, it means 2 times what? 10 raised to power minus 3 henry. Please note all this, very important, while you are doing your conversion. Yes, they are very important. We want to see how to solve important questions, IQ questions, on this alternative current circuit. Let's see some questions, very important.